Hey guys, Al here, Vitalize Seed. Hope everybody's doing well. So we've done quite a few videos as of recently on soil and soil health, and we talk about the chemical structure a lot, which is the CEC, the base saturations, your pH, etc. Obviously, the physical is something that's going to be, the texture of your soil, what type of soil it is. Now that might be represented by things within the CEC. That's why I like the Venn diagram, because it shows the relationships between the different populations of information. So under physical health, under chemical health, and then of course how those overlap with biological health of the soil. And that's a really important piece of the whole puzzle, is the biological health. So as you see here, it's all interconnected, and when you have all three parts working together, that's when we kind of reach the epitome of soil health, and we can maximize our soil health. You really need to think of all three components. Obviously, with the biological piece, it's super in depth. All of these pieces can be relatively in depth, but the biological piece, we're still learning more every year. The smartest soil scientists in the world are. What we like to do at Vitalize Seed is focus on carbon and nitrogen ratios, biological diversity with root structures. We want to focus on keeping a living root growing, and having one feeding feed the next, and the next feed the next, right? That's where we have our 1-2 system. The first feeding feeds the second seeding, and the second seeding feeds the first. So we focus on this through having diverse root structures, a living root, keeping the soil covered. We're a big proponent of no-till or limited till. For those of you that are going to be using tillage, we want to heavily reduce that using conservation tillage. What are some things that biological aspect of soil encompasses? One that I think would be helpful to talk about today, and there's so many, but just for the length of the video, we don't want to make it several hours long, is when you have no-till environments, we're all familiar, or most of us are familiar with mycorrhizal fungi and the mycelium. So basically what happens, you have roots growing, and they're having root exudation occur, and it's creating a biological stimulation to your microbes and your fungi. And mycorrhizal fungi are essentially, the mycelium goes into the root hairs, and it extends your root network by volume. So where your roots would normally, let's say, only encompass this much, you now have this synergistic relationship with the mycorrhizal fungi, and mycelium is essentially the conduit that connects those two together and goes into the root hairs, and it now extends your root mass in a far greater network within the soil profile than it would have been if it was simply the roots. This only happens when you have a biologically active soil. When you till, you disrupt that mycorrhizal fungi network. You either chop it up, or you literally can dry it out, etc. So we want to keep that in mind. That's why we're such big proponents of no-till or very limited tillage, is we want to extend that. Now, when you extend that root network through this mycorrhizal fungi connection, it allows your now new root volume by mass, right, to get solubilized nutrients, because the mycorrhizal fungi is very, very good at this, not only from a communication perspective, but also from a nutrient solubility perspective, within the layers of soil that the root mass might not have been having access to otherwise, because you're literally extending the outreach, right, the communication streams, think of it that way, into the soil, and you're able to solubilize more nutrients. It's easier for the plants to uptake those nutrients. From a biological perspective, the plants are actually taking up nutrients in different forms. So literally from the microbial form, which is allowing plants to uptake nutrients in the amino acid form. So it's an easier plant protein conversion versus if it's just taking it up in pure nitrate form. And that goes into Dr. James White, the rhizophagy cycle. So this is just one step. Now, when that is occurring, and the mycorrhizal fungi is actually creating something that's called glomalin. Ray Archuleta infamously calls this biotic glue. So we talk a lot about soil aggregation from a chemical side, but we can't underestimate the power of the biological piece for soil aggregates to be formed. What is a soil aggregate? Just think of it's the ability for soil to hold together. So you can Google glomalin, soil aggregation, and what you'll find is soil that has glomalin in it is a dark, rich color, and it looks clumpy, for lack of a better way. Maybe some people have defined it as chocolate cake, but there's a texture to it. Again, as Ray Archuleta says, a biotic glue. Soil without glomalin is like dust. Well, why is that important? Well, when you have that structure, it helps from a water infiltration perspective. Obviously, it helps from a biological population and movement perspective in your soil. It helps from a soil structure perspective, etc. So without getting too far in depth, hopefully that helps you guys, at least for part one of this. I'm not sure how many parts we'll do, but I'm sure I'll hit on this more. But the three aspects of soil: physical health or physical structure, chemical health or chemical structure, and then biological health. And of course, biological structure being it with the glomalin and other root exudations that work as those biotic glues to hold soil together. So get outside, enjoy the outdoors, guys, and check us out at vitalizeseed.com, where we try to make biology work for you.